Okay, so we are here working on hexadecimal and learning about hexadecimal. So hexadecimal, with binary, is really hard for humans to kind of look at and understand what the number is. But binary is really easy for computers. Decimal is really easy for humans to understand, but hard for computers to use. So hexadecimal is kind of a compromise that humans can kind of get, and computers can kind of work with. So hexadecimal is, hex is 6, decimal is 10, so hexadecimal is base 16. And like we looked at with binary and decimal before, the groups of hexadecimal are based on powers of 16. So you got 16 to the 0, which is a 1, 16 to the first, which is groups of 16, 16 squares, groups of 256, then you got 16 to the third and 16 to the fourth, right? And so these are all different groupings of the powers of 16. We will use mostly these first four in our work here today. How do you count in hex? So on the top is how you count in binary. On the top is how you count in decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The bottom is hex. 1 through 9 is the same. 1, 2, 3, 4, 5, 6, 7, 8, 9. When you get to 10, we don't have a group of 10 yet. So 10 is represented by an A. 11 is represented by a B. 12C, 13D, 14E. 15 is represented by an F. When we get to 16, in hex, it's 1, 0. We have one group of 16, 0 left over. So 8 in decimal is 8 in hex. Same thing. 12 in decimal, and again, I have my cheat sheet down here at the bottom for you. 12 in decimal is C in hex. 15 in decimal is F in hex. And then 16 in decimal is 10 in hex. One group of 16, 0 left over. Okay? So 20. So ask yourself, how many times does 16 go into 20? I got the little cheat sheet up here, and you can see 16 times 1 is 16. What's left over? 4. So the answer is 14. One group of 16, 4 left over. 16 plus 4 is 20. How many times does 33? 16. How many times does 16 go into 33? Goes in twice. 16 times 2 is 32. What's left over? 1. So 21. Two groups of 16, 1 left over. For 45, goes in 3 times, right? With 3 left over. I'm sorry, I did that totally wrong. Goes in twice, right? It's 48, 45. So it's 2 groups of 16 with 13 left over. Okay? 2 groups of 16 with 13 left over. It's 2D. Then for 56, it goes in 3 times with 8 left over. So 16 times 3 is 48. And then 56 minus 48 is 8. Okay? So we're going to start letting you kind of, hopefully this is review. So go ahead and pause the video and see if you can convert these decimals into hex using the cheat sheet here at the bottom or the cheat sheet here at the top. Pause the video, work it out, and then we'll come back and show you the answers. Okay, let's take a look at the answers here. We got 3 groups of 16 with 13 left over. 13 is D. 78 is 4 groups of 16 with 14 left over. 5 groups of 16 with 9 left over. And 5 groups of 16 with 15 left over. Okay? Hopefully you've gotten that down a little bit. Go ahead and pause the video and run through these real fast and see how you do at converting them. All right, let's take a look at the answers here. I'm just going to kind of play them for you, and you can check to make sure you got them right. Here you go. Now, figuring out how many times 16 goes into the number, subtracting it, and then seeing what's left over. That's a good way to do this. It's a safe way. You're just doing simple subtraction. You might, though, want to learn the shortcut. So the shortcut works like this. If I want to convert a decimal to hex, first I have to convert it to binary. So it works like this. If I want to convert decimal number 44, I first convert it to binary. So this is 44 in binary. Notice the groupings at the top, right, for a byte of information. Then I take the I take the binary number and I split it up into nibbles. So a nibble is 4 bits. So here's 4 bits, that's one nibble. And here's the start of another 4-bit nibble, right? Then for each nibble, you restart the numbering system. So it's 1, 2, 4, and 8, 1, 2, 4, and 8. Those are those groups. Then you just convert the individual nibble from binary back to decimal, or back to hex, I guess I should say, right? So here we have one group of 2, 0 groups of 1, so that's a 2. You say 2 in hex. Here we have one group of 8, one group of 4. 8 plus 4 is 12. In hex, 12 is written as a C, so 2C. So 44 in decimal is 2C in hex. Let's look at another example. Here, I'm converting decimal 110. So the first thing I got to convert that to binary. So here's our groups in a byte of information. Here's our groupings in binary. Here's 110 in binary right here. I am splitting that binary number up into 2 nibbles, or 2 sets of 4 bits. Then I'm renumbering the nibble, restarting the groups from 1, 2, 4, 8, 1, 2, 4, 8. Dropping down now the same binary code into each nibble. So this is just dropping down here, and then we're converting it. So I have a group of 4 and a group of 2, that's 6. And I have a group of 4, 8, and 2, it's 14. So 6, 14, but how do you say 14 in hex? 14 in hex is E, so it's 6E. Okay? It's important that you kind of get comfortable with this shortcut, this conversion method, because we will be using some larger numbers where doing it the other way is really just not practical. You're going to have to learn this and do it this way in order to accomplish the conversions on paper. Okay, so let's go ahead and practice that a little bit. Go ahead, and I've already given you the binary number of this decimal number. So now all you got to do is convert this binary into 2 nibbles, reset the groupings, and then add them together. So 149. Here's the same binary number into 2 nibbles. An 8 and a 1 is a 9. You got a 4 to 1, that's a 5. So this is written as 95 in hex. 202, right? So 202, again, taking binary, divided it into 2 nibbles, adding the nibbles together. So a group of 8 and a group of 4 is 12. And 8 and 2 is 10. 12 in hex is a C. 10 in hex is an A. So it's CA. Go ahead, and again, if you're comfortable with the system, go ahead and pause the video and see if you can convert these on your own. And then we'll come back and show you the answers. All right, let's take a look at the answers here. 230 in decimal is 6E in hex. 255 in decimal is written as FF in hex. So again, you're just writing those out and converting them, and then writing those numbers in hex form. 256 in decimal is 100 in hex, because we have one group. If you remember, 256 is that next group up. So we have one group of 256, 0 left over. Okay, go ahead then, and again, pause the video. Hopefully you're getting the hang of this, and convert these numbers, and we'll come back and take a look at the answer. All right, let's take a look. So 286 is 11E. 628 is 274. 947 is 3B3. You can see how we're converting there. 111, or 1,111, is 457. And 1355 in decimal converts to 54B in hex. Okay. Now, I want to point out, you'll see this on the test and in other places around technology. If you notice the 0x in front of a number, that's telling you that the following number is a hexadecimal number, right? Because if you could have a number like 14, is that decimal is hex, right? Well, if you have 0x14, you know that 0x is telling you it's a hexadecimal number. So this number right here is telling you, oh, that's a hex number. I also put these two videos in here. If you're still confused on what I'm saying, sometimes hearing it from someone else in a different manner helps you understand it better, makes it click. So you can look at these videos and kind of goes over how to convert hex to binary and hexadecimal. Kind of what I'm doing here, but in a little bit different way. So use those if you need to. Okay, so we're going to go ahead, and these are hex numbers now, and we're going to convert them to binary. We convert it by reversing the process, right? So here, I'm taking the hex number, B284, and looking at each one as a nibble. So each one is 4 bits. Then converting a 2 in binary is a 1, 0. B is 11. You write 11 in binary, 1, 0, 1, 1, right? 8 in binary is 1, 0, 0. And 4 in binary is 1, 0, 0, right? So once you have this, then you know what, then you just add these, you just put these numbers together, and it gives you what the binary equivalent is. Okay, go ahead and convert the next couple here. Go ahead and pause the video, convert the next one, and then you can pause the video, do it, come back, and we'll show you the answers. All right, let's take a look. So C638 converts to binary with this way. The next one, 9BC2 converts to binary this way. And then 3DA7 converts to binary. And then 0F, and that is a 0F3E, converts to binary this way. So that's how you go from hex to binary. And then you also will need to know how to convert those to decimal. So here are the decimal versions of those same numbers. Well, how do I get those decimal versions? Well, let's take a look at that. So to convert hex to decimal, we first got to remember our groupings up here, right? Remember our groupings? 16 to the 0 is the individuals. 16 to the first is groups of 16. Then we have groups of 256, groups of 4,096. And again, for this assignment, we're really only going to use these first 4, right? So how does that work? Well, you take those groupings that we use in hex, right? And then you put the hex number underneath each one. And it's saying we have 2 groups of 4,096. Well, 2 times 496, 4,096 is 8,192. B is 11. We have 11 groups of 256. That's what it equals. We have 8 groups of 16. That's what that equals. And we have 4 groups of 1. And if you add up all these numbers here, we get our decimal number of 11,140. So go ahead and pause the video, figure out the rest, and we'll come back and show you the answers. It's the same system that we've been learning and been doing, just with different groupings at the top. Okay, let's take a look at the answers. So here is the next one. C6-3A If you add those numbers up, it's 50,746. The next one, right? Convert each nibble to a decimal. Add those up. It's 39,874. Then we've got the next one here, converting it to a decimal here. Each nibble is converted to a decimal. Add those numbers up, and we got 15,783. And then the last one, if you add up all those, the answer is 3,902. All right? So again, just don't look at the big, don't be overwhelmed by the big picture. Break everything down to a very small mathematical problem. And all we're doing here, guys, is add, subtract, multiply, divide. That's all we're doing. Add, subtract, multiply, divide. This is not higher math. Okay? All right, so we're going to have you practice this now, and we'll have a worksheet for you to do. It'll look like this, where I'm giving you one of the numbers, and you're converting it to the other two. So here I'll give you the decimal. You convert it to binary and hex. Here's binary. You convert it to decimal and hex. And then again, here's hex. You convert it to binary and decimal. Okay. Good luck to you. And if you have any questions, as always, come and see me, and we'll work it through for you.